Hey everyone, welcome back. So today we gonna solve a classical mathematical problem where we need to find out whether a given number is a perfect number or not. Okay, so if you want to read out this problem statement, you can pause the video and give it a good read. Meanwhile, let's see what we understood from this problem. So we need to write a function that determines whether the given integer is a perfect number or not. Perfect number is a positive integer that equals to the sum of its proper positive divisor excluding itself. Did you understand anything from this statement? No, right? I also didn't understand. So let me explain you with an example. Basically, the input here is 6 and the output we are getting 1. Okay, so let me give you an example. So let's say this 6 is given to us. Okay, now if I say tell me some numbers which are less than 6 and can divide 6 fully, means the remainder should be 0. So if we can divide it by 1 6 times, so we will get 0. We can divide it by 2, we will get 0. We can divide 6 by 3, we will get 0. Now what if I say sum all these numbers? So what answer you will get? So if you sum all these number 1 plus 2 plus 3, you will get 6, and that's what written over here. That equals to the sum of its proper positive divisor excluding itself. I hope you got the understanding. What basically we need to do, if we get this thing that sum of their divisor is equal to the number itself, in that scenario we just need to return 1. Okay, else what we need to do, we just need to return 0. Okay, this is what we need to do. So let's see what is our approach. And one more thing, I also wrote the explanation over here, so if you want to read out, you can do that as well. Now let's see how we gonna approach this problem. So we will start by giving a number n, then we will iterate from 1 to n minus 1. For each iteration, if the current number is a divisor of n, we will add it to the sum of a divisor. Okay, and after that we will check if the sum we get of, okay, so if it is equals to the number, so if it does, then we will return 1, else we will return 0. So this is what we need to do. So let's write the code for this. Okay, so let's quickly go over the problem. So what we are doing here is basically we have taken the user input n. Okay, then we are providing that n to our isPerfect function. So this is our function, and then we have created this sum divisor variable initialized to 0. Then we are running a for loop from 1 to n. We are dividing our number by by 1 first, then we will divide it by 2, then 3, then 4. Okay, so if that number can divide this our given number n properly, in that scenario we will add that number to our sum divisor. Okay, and then so let me explain this. So let's say here our 6 is given and this is 6. Okay, now if the first number we will try is we will divide 6 by 1. So is it equals to 0? Yes, so we will add 1 to it. So 0 plus 1 is 1. Now we will divide it by 2. So can it will n be divisible by 2? Yes, so we will store 2, so it will become 1 plus 2, that is 3. Then we will try with 3. 1 plus 2 plus 3, that is 6. Now we will, so now inside this sum divisor we have 6, right? We will check if 6 is equals to 6. Yes, so we will return 1. That's what we are doing. And let's say in some scenario it's not equals, then we will return 0. Correct? So let's run this and see even if it is working or not. So let's give it 6 and we are getting 1. That is correct. Now what optimization we can make over here is, so basically we are running our loop from 1 to n. So what we can do, we can check this one. Like let's say user only provided us 1, so then no need to run this loop, right? So we can write a if condition. We can say if our n is equal to 1, then directly return 0, right? Because we do not have any divisor for 1 which is less than 1, so we can do that. Another optimization we can make here is I would say this. So if we already check 1, then it will start from 2, okay, and then we can do these steps, and instead of running this loop till n, so what we figure out here, so when we give 6, right, when we give 6, so we get our output, so we can divide 6 by 1, 2 and 3. So if we, what does it mean? It means that let's say I divide 6 by 2, so what I will get, half of 6 is 3, so the divisor we get is till 3. So if we try to divide it by 4, it is not divisible. So if we take the example of 12, so if the half of 12 is 6, right? So if we try to divide it till 6, it can be divisible, but if we try to divide it by 7, 8, we can't divide 12 by 7 or 8 or any number which is greater than its half, right? So instead of running till n, we can run it till the square root of n, okay? So this will drastically improve our performance. And so because we are not checking 1, okay, we are starting it from 2, so 1 is can always divide a number, so whether it is 2, 3, 4, 5, 6, so 1 is always a divisor of that, right? So we can initialize it to 1, okay, and then so here we are checking if our sum of divisor is equal to n. So what we can do, okay, then we can make some optimization here, like let's say because we are finding the square root, so we need to make sure that we do not count the number twice, okay, and then instead of directly basically this storing like we are saying divisor is equal to n, right, and we are storing the sum inside this divisor, so we need to make optimization that we will first divide a number by I, right? So to make sure that we do not have any duplicates, right? So we need to do that, and finally we can put this if else condition, this returning statements in a single line. So let's write the approach. I don't think just by telling you will understand, so let me write that and then I will explain. Okay, so we have wrote our program. So what we are basically doing over here is we are taking the user input and passing it to our isPerfect function. This is our function. We are checking if n is equal to 1, then we are returning directly 0. Then we are checking if the sum of so basically here we are setting it to 1, okay, because we already check our 1 and we are setting it to 1 as I said, like because we know that for every number, okay, so 1 is always a divisor, correct? So that's why we are setting it to 1 by default. Now we are finding the square root using mat.sqrt. So once we get the square root of n, then what we are doing, we are using this for loop, we are running it from 1 to the square root. So as we discussed, we can run till the half of that number, okay, that's why. And now we are checking if we divide the number, if that number is a divisor, in that scenario we will add it inside the sum divisor variable, okay. Now we will check if our divisor is not equal to n divided by I, okay. So what we are doing here is basically we are checking if we are not storing the square root like twice, okay. So for that we are doing this thing, and if we are doing this thing, then instead of adding n, we need to divide this by the divisor, okay. So this is what we need to do, and finally we need to return 1 if some divisor is equals to 1, else what we need to do, we need to return 0. Okay, so let's run this and see what we are getting. So let's give it 6 and it should return 1. It is returning 1. And what if we give it 1 as input? So is it returning 0 or not? Let's give it 1 and it is returning 0. So our program is basically working fine and as expected. And there you have it. So we have explored how to detect a perfect number using Python. Thanks for watching. Do not forget to like, comment and subscribe for more Python programming content. See you in the next video.